All right, welcome everybody to our last video for the IA. And so I just want to review what we did in the first two videos. The first thing that I did with you was I went through the PowerPoint presentation, talked to you about what an IA actually is. The second thing that I did with you was I graded an IA with you to give you an idea of what an acceptable project looks like. And now the third thing that we're going to do is we're going to talk about specific IAs that I've received and which ones I thought really went well and why the ones that didn't go well, what the issues were. So, your job for this summer really, before we do that, is to come up with the following summer project here. And again, this isn't due on the day you get back, it's due on Friday, September 18th. And that date has a little bit of flexibility in it, but the first thing that you need to really do, first of all, is come up with a research question. So really come up with a research question and a hypothesis of what you're going to study. From there, you could frame out what the title would be. You should have a personal engagement, about half a page. You should have an introduction that includes background, and that's going to be part of the exploration part. You should have the materials needed, an idea of what your procedure is going to look like, and then any plans that you have for data analysis. And then start gathering citations, start gathering, making a bibliography, because that's going to become important. You need to have citations in your work. So this is what I'd like you to hand in. Now this is graded pretty loosely by me. And again, I'm available for you to talk to. You can just email me at kleins@northshoreschools.org. So let's talk about some of the experiments that have been done in the past. So the first one here, it says analyzing the effect of concentration and temperature on sodium hypochlorite bleach on disinfectant rate. And basically what this student did was they took a little like hole punches and they dipped it into bleach, and then they put it on a plate that had bacteria that they plated on it, and they saw how the bacteria were inhibited. Now it seems like a pretty straightforward experiment, and the idea would be to measure, what they call the zone of inhibition is, like how far from the little hole punch did the bacteria fail to grow. But the problem became that it wasn't just a nice circle. It was weird, and then they had to do a lot of work to kind of figure out the difference in the bacteria that were grown in the presence of bleach and the bacteria that were grown not in the presence of bleach. And this project, it's relevant even to today because, with the coronavirus and people saying to sanitize and disinfect things, you could try different sanitizers and disinfectants. You can't obviously work with coronavirus, but there are bacteria like E. coli that you can, grow and you can experiment with that. The second one that I highlighted, number 2, how do varying salt concentrations affect the rate at which iron nails rust? So this student made different concentrations of salt solutions and put the iron nail in. And, they wanted to see how much rust there was. But the problem was massing the rust. So how do they mass the rust? Well, they had to take the nails out of the solution pretty much every few days. They had to scrape off the rust, and then they had to mass it. And so that was a challenging experiment. Seems like it would have been pretty straightforward, but they did it by mass, and they massed the rust that formed, and it was hard to find that mass. Number 4, exposing spinach chloroplasts to varying concentrations of calcium chloride to observe the effect on the rate of photosynthesis. So this was a bio student as well. They were taking biology, so it was easy for them to get the chloroplasts and easy to get the calcium chloride. And then they measured the rate of photosynthesis by using a spectrophotometer. That was a pretty straightforward lab, and they were able to get a lot of data. So that was pretty good. Number 7, the accuracy between a micro and macro titration. So the student was interested in talking about green chemistry. So can we save reactants? And they did that by comparing the accuracy of a micro titration that uses very little acid and base to a macro titration. Number 8, how effective are filtration systems for filtering out lead nitrate? This was during like the Flint, Michigan crisis. And so the problem with this experiment was that first they had to find different filtration systems. So they were using like Brita pitchers and pure pitchers and other things like that. And then the issue is though that like they poured through the lead nitrate um, and then try to precipitate out any lead nitrate that was left. But then how many times can they use the filter? They didn't really test that. It had a lot of issues. They couldn't really get a lot of data points, so that wasn't a great result for them, but it was an interesting experiment. Number 10, the experimentation of pH values on the temperature at which liver enzymes denature. Again, this was another bio student, and so they put the liver pieces in different pHs, and then they measured their activity as a function of temperature to see, oh, if I have it too acidic, it'll denature at a lower temperature. That was interesting, and that took some time to do, but when they set it up and they got it going, it was kind of cool. The concentration, correlations between electronegativity, conductivity, hardness, and density in various metals. This was a virtual lab. And this student, they could have done like a really great job of this, but I felt like this really highlighted what could go wrong with a virtual experiment because they didn't put in the time to really analyze the data. They collected the data, by looking at different sources, but then their analysis of it wasn't deep enough, and that hurt them. Number 21, determination of iron ion concentration in iron supplements using permanganate titration. So this was a redox titration. This was a neat little experiment. First they had to dissolve the iron, and then they had to titrate it. And that took a long time actually because they had a lot of samples, but they were able to yield pretty good results from that. Number 23, that was an examination of electrode surface area in a Voltaic cell. So they changed the surface area of the electrodes. Unfortunately, we didn't do a Voltaic cell lab like we normally do, so you didn't get to experience that. But what they did was the way that they measured the voltage, like they did a time lapse and they were able to basically make graphs. And the issue that I had with this was that the math was very complex. This took like a very special student to do it. They were doing calculus and integration on the curve to figure out the effect. So they did a great job and they got a good score. I didn't understand the math as much as I would have liked to. Their moderator did, so that was good. Number 26, potential differences in unsaturation. So this was another type of titration lab, and this person was looking at different butters, and they were looking at differences between the unsaturation, so how much saturated fat was there, depending on where the butter came from and how the cows, were raised and what they ate. So that was a great experiment. People, they did really well on that one and got pretty much close to a perfect score. The varying effects of catalyst concentration on a sterification reaction. This took actually like a lot of background work for them to figure out what calculations they were going to do. And so that was a challenging experiment, but it went well. And the effect of carbon length on number 34 and carbon length on on concentration, temperature, and temperature of carboxylic acids on the percent ionization. So they basically took different acids and they changed the temperatures of them. They were all organic acids with carbon chains, and they looked at the concentration, the temperature, the chain length, and they measured the pH at all those different conditions, and then were able to calculate what percentage they ionized to. So, like these are just some examples. I highlighted ones that I thought were like interesting. Some of them had pitfalls. All of these people really tried to do a good lab. You could also go back and do and look at the other IAs that we did last time. The other labs that we did last time to design an IA around. So there's things like we did the density lab, physical chemical changes. We did a calorimetry lab, separation of a mixture, model building lab. I don't really know how you would apply that, but you could use models in your analysis. IMFs and evaporation rates, percent composition of the hydrate, gas collection labs, freezing point depression. A lot of students like doing that kind of freezing point depression stuff. Solubility curves, equilibrium lab with the chips. We didn't get to do that last year. So, some of these we didn't get to do at the very end of the year. So my advice to you is over the next, few days, while this is still fresh in your mind, don't wait. Start really thinking about what would be a good research question to ask about chemistry. You can look at the other 9 papers that are on my website and also posted on Google Classroom. You can look at more closely at the titles that I published or that I posted here. And you can also look at your old labs. And you could search Google. I've had some kids go and search like great IA idea. And they've come up with stuff and they've changed it a little bit. What you really need to be careful of, though, is you can't just copy something word for word. The academic integrity is intense here. If you're going to take an idea that you saw and you want to change it and test a different variable, that's fine. That's how science works. People do one experiment, somebody else reads that experiment, the paper on it, and say, hey, why didn't they test this? And then they try and test it. This is the same kind of thing. So, get to work. And if you have questions, again, I've told you many times my email, kleines@northshoreschools.org. And I hope to, hear from some of you. Shoot me an email with your ideas and just be like, I'm thinking about doing this. And I'll say, well, how are you going to measure that? Or what are you going to do for this? And hopefully you'll be able to say, yeah, I can, do this, this, and this to measure that. Okay, so thanks so much for watching, and I hope you're all having a great summer, and I hope to see you all soon. All right, thanks so much.